Hi, everybody. My name's Kris Erickson. I'm a professor in Create at the University of Glasgow, and I'm leading a course called Technology Regulation Maker Lab. And this semester past, the students were working with large language models to create prototypes. And through the course of that, I got super interested in what the students were able to do and learning alongside them some JavaScript and other coding and using these large language models to create software prototypes, I thought, well, I should do my own project and learn as they are. So I did some thinking about what I wanted to do for a project. And I was inspired by an article from 2018 by a scholar named Nicole Lammerts. So Nicole's paper was about how AI was going to really have an outsized impact on fan communities and fan expressions, which was super prescient, I think, because this was, as you know, way before ChatGPT. And so she was already seeing how fans, like fan fiction writers and other creators, were going to be using large language models to produce content and to interact with the stories that they love. So inspired by that, I thought, well, why don't I do something to do with sort of fandom? And being a fan of the show Stranger Things, I thought, okay, let's do something with that. So what I'm going to show is a prototype of a text adventure game that's based on the Stranger Things canon and uses large language models to sort of interface with materials from the show in various ways and enrich the project. So let me just share my screen and we can walk you through it. So the graphics are very basic. Given my basic level of software coding, I'm just still learning JavaScript. So we're really in the realm of text adventure, and there's a little bit of ASCII art. Some of it is mine. A lot of the ASCII art is from skilled people on the internet who've made stuff, and I've sort of adapted it for the game. But that's not the main focus. The main star is the large language models, which we'll talk about. So the one way that we're using the large language model is we're doing retrieval augmented generation. So essentially, we're taking existing models, which are already trained on a whole bunch of text, but we're giving it access to new and specific text to help it come up with something which is relevant to the user, right? And so in this case, what I've done is I've fed it a bunch of text, which has been scraped from the wiki, the fan wiki for Stranger Things. So this is a great website, which is volunteer produced by fans of the show, and it really detail sort of encyclopedia of everything that happened in the show. So there's a lot of text there describing the various locations and things like that. And it also online you can find the sort of unauthorized scripts of the show. And I've also taken chunks of dialogue from the show and fed that in as well so that the model, when we visit the different locations, can populate it with dialogue, which you might hear between the characters in real life, or at least in the show. So this is the central hub. We can go north to the arcade, which was one of my favorite locations from the start of season two as a big arcade history nerd, south to Hawkins National Lab, east to Mike's neighborhood, or west to the middle school. So let's go west to the middle school just to get started. So we can change location. So here we are in the middle school. Now, let's investigate the area. And when we do this, we'll see that the model is going to do its magic. There we go. Now, one problem is it's a little bit slow because these language models are fairly still computationally intensive. We're using our own server. Oh, here we go. This is the answer. So as you approach Hawkins Middle School on a crisp morning, you notice a bustling atmosphere. Students are milling about outside, chatting, laughing as they head to their first class. The sound of lockers slamming shut. So we can imagine ourselves in the show. Here's Scott Clark, the science teacher. So it's picking out characters from the show and populating it. He's a tall, slender man with a mustache. It looks like he's keeping a watchful eye over his charges. You see Will Byers, Mike's friend who went missing, walking, well, he's no longer missing, walking down the hallway, looking slightly nervous, but otherwise okay. Dustin, Lucas's friend, and they even break the fourth wall and they address us. Hey, new kid, what brings you to our neck of the woods? So we get some dialogue and some interaction with the location. Now we can do it again, and we'll get a different text. And this is what's so great, I think, about the language models is it can obviously rapidly enrich a interactive experience by providing a lot of content. And the content can be, in this case, informed by, the existing canon of Stranger Things. So um, here's a different depiction of Scott Clark. Now he's standing outside the school. Um, and um, and look at this. So there's a text here. Hey, new kid, you should try to beat my score in Dig Dug at the arcade. So this is a clue which I've seeded into the data which is fed to the large language model. So, if you've played text adventure games of the past, you sort of like would get stuck on a puzzle and you wouldn't know how to advance. And then you'd have to sort of search around the world for clues. And when you find a clue, then maybe you could solve the puzzle and get ahead. Here, what I'm doing is I'm just putting some lines of dialogue into the big text, which is fed into the language model to generate these descriptions of the area, in the hopes that randomly one of those will appear and the user might be stimulated by the clue. So here the clue is that we should make our way to the arcade and try out Dig Dug because we might trigger something further in the game. So let's do that. Let's go to the north um, and investigate the arcade. Now, as I said, this we have to wait a few seconds for the text to appear. That we're using here, we're using Llama 3.2. Which is a really competent but fairly small model. So the responses are coming back more swiftly than they would with some of the others. I was getting really great results with Qwen 2.5 Coder, which is a 14 billion parameter model, but that takes like up to 10 seconds to get an answer, so it's not as sort of smooth for playing. My colleague Felix joked that this is the first text adventure game that you would need an NVIDIA 4090 as like the minimum specifications to run. Not quite that crazy, but clearly, it's a lot beefier than you would need for a text adventure game. So here we are in the Palace Arcade. It's describing characters like Keith, who is a frequent, appeared in the arcade. We're watching Dustin try to beat his high score in Centipede. So this is cool. That's really, I think, the benefit of incorporating the large language model in an interactive experience. It can produce this content every time it's new, and it's informed by things like the day and night cycle in the game, and it can pull in. You can pull in variables from various places, put it into the prompt, and use it to sort of craft the content which the model gives you. Now, following the clue, let's try to play Dig Dug. Oh, so we could have played Dig Dug, but we don't have a quarter. So we're gonna have to find that quarter. Now, I know how to solve that clue. There are quarters, hidden in various parts of the game, which you can find. But essentially, we don't need to walk all the way through the game. Let's skip ahead to the ending of the game. And I just want to show this because it's a different use of the model. So we can actually go down once we've unlocked the secret area below the city. And here we can enter the boss fight with the Aqua Gorgon. So let's go ahead and do that. Okay, so the Aqua Gorgon towers above us. Our inventories are our clothes and a skateboard. What do you want to do? So let's try to fight the Aqua Gorgon and see what happens. So doing this, we're actually going to use, again, the language model to determine the outcome, whether we're going to win or lose against the monster, and then to describe the fight as if it was sort of like a Dungeons and Dragons like campaign. So let's see what happens. We steady our nerves and lunge toward the monster. Here, unbeknownst to the adventurer, Aqua Gorgon's very nature was a curse. Its ability to breathe underwater was paired with an aversion to light. I hope we have some light-emitting devices in our inventory, or we're going to have trouble. So we're tattered clothes. We're grasping a skateboard, which seemed to almost comical against this gargantuan flow. So you can see I'm feeding the inventory items into this final battle so that the model knows what we have in our possession and is going to use that as part of its decision about whether we win or we lose. The solo warrior stumbled backwards, desperately seeking an escape route from the monster's crushing coils. We're not doing well. The skateboard attempts at defense were nothing more than a laughingstock as the Oracle Gorgon wrapped its colossal body around the board, sending it flying into the darkness. This isn't looking good. Undeterred, the Gorgon lunged forward, unleashing a torrent of icy water. Um, and oh, it's extinguishing our last flicker of hope. In the end, only a sodden, lifeless body floated to the surface. So we died to the Aqua Gorgon. Let's go back and let's do this differently. So another feature of the game where we're using the language model is to try to recreate that feeling at the end. You know, at the end of season one, when they're trying to gather all the items from the hardware store to build a trap that can defeat the Demogorgon. You know, let's try to recreate that because that was one of my favorite parts of season one. So what we can do in the game is we can search for objects in the world and add them to our inventory. So here we're searching in the arcade. We found a dust collector. That doesn't sound very exciting. Let's throw that. And search again. A reel of neon bright tape. That could be useful, especially knowing what we do about the final boss's weakness to light. So let's keep that in our inventory. Let's search again. Analog pinball machine. Cool. So here we're using a model to propose inventory items that you could plausibly find in the given location. And it's infinite, right? Because it's a language model. So these are not items which have been coded into the game. These are just strings of text which are being proposed by the model. And I find that super interesting, and it's something to get our heads around. You know, it's really different from traditional game design, where like if you don't put the item in the game, it won't be in the game. Whereas with these models, you know, there's really no limit to the kinds of things that you can have in the game. So if we search around in the middle school, we'll find things to do with, you know, middle school. Uh, and an old photocopy machine. Let's nick that from the school, right? So keep that. Search one more time. An old school alarm system manual. No, that's not good enough. We want something like old-fashioned school radio transmitter. Let's keep that. Okay. So now, if we check our inventory, uh, we've got not just our skateboard, we've got tape, we've got a pinball machine parts, we've got a photocopy machine, and a radio transmitter. Let's see if and we can search here in the tunnels too. Let's search in the tunnel. A dust covering manual. We don't want manuals. We want real stuff. Uh, the underwater tunnels here don't have much good stuff because they're kind of abandoned. Metal pipe fittings. Okay, we'll try that. Anyway, let's now fight the Demogorgon again. Now you see we have a bunch more stuff in our inventory. And let's see how this plays out. Again, thinking of it in terms of like a Dungeons and Dragons campaign, or a little bit like a cross with that show MacGyver, where you know the main protagonist had to like assemble things from various parts. Can we actually now defeat the monster based on these items? Let's see. Okay, so with a few twists of the reel of neon bright tape, the adventurer created a dazzling array of colorful obstacles, entrapping the monster in a web of swirling lights and patterns that left it disoriented. As the Aqua Gorgon thrashed about, its sensitive eyes became overwhelmed with a cacophony of sounds emanating from the old-fashioned school radio transmitter. So this is awesome that the model can sort of creatively take our various you know, inventory items, kind of like a game master would do in a D&D campaign, and sort of weave a really cool story that is customized to the player, their inventory, and other things that the designer can set. So with a final decisive blow, the adventurer struck the creature down, emerging victorious from the depths of the underwater lair. So this time we were victorious. So this is in a nutshell what I've been experimenting with. First of all, trying to enrich the descriptions of places and the dialogue from real events in the show, sort of help maybe imagining that if users can be more satisfied and have a deeper, enriching interaction with a fictional world by sort of being able to talk to, if you like, an AI which has been trained on the lore of that world. And then on the other hand, using it in other ways in terms of like facilitating the game design, making it easy to have a final boss fight, because this really boils down to sort of text, win or lose, describe the outcome. We're dealing with strings of text rather than, variables and items, which have to be laboriously programmed. So one of the things we want to explore, I think, further is like what kind of combat systems or like challenges or puzzles can you imagine that can be enriched by using these AI tools? And in general, just harking back to that article that I said was influential from Nicole Lamerich's, I really do agree that she's got a great point that I think fan experiences are going to be among the ones which are going to be impacted the most by AI, at least in the near term. But of course, this has all of the attendant copyright, IP, and other regulatory issues attached to it, sort of like fan fiction already has. But I don't think there's any stopping this type of thing from being made. So thanks for watching this demonstration, and I'll hopefully see you soon.